In this video, I will explain how to convert from one number system to other number system. So we have binary number system, so in which we have total number of digits are 2 in decimal 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. In octal we have 0, 1, 2, 3, 4, 5, 6, 7. In hexadecimal we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and from A to B, C, D, E, F. Each number system has a base value, and that is, for binary we have 2, for decimal we have 10, for octal we have 8, and for hexadecimal we have 16. So whatever the total number of digits available in that particular number system is the base. So in binary we have total number of digits are 2, so base is 2. In decimal we have total number of digits are 10, so the base is 10, and so on. To convert any decimal number to any other system, the simple rule is that divide the decimal number with the target based, and whatever the remainder is coming, just write in the upward or in reverse order. I will just take an example and then I'll just explain it. So just take one number, let's say 88, and I'm just creating a table. This is decimal, and for hex base is 16. So we have taken this as a 88. So now we have to convert this 88 into binary. Okay, so we have to divide this number with the 2. Okay, so I will divide 2, then it will come 44, and remainder will be 0. Again I will divide this number with 2. We have to continue this process until the number becomes 0. So it is 22. So 22 into 2 is 44, the remainder is 0. 2 into 11, 22, again remainder is 0. 2 is to 5, 10, remainder is 1, and then 2 into 2 is 4, the remainder is 1, and then 2 into 1, 2, and then remainder is 0. So now we have to write this remainder in reverse order. Okay, so this is 1, 0, 1, 1, 1, 1, and then 1, 2, 3. So 1, 2, 4, 8, 16, 24, 32, 64. Yes, so this is 88. Now let's convert the same number in octal. So as we know, the octal, the base is 8, so we will divide this number with 8. So 11 into 8 is 88, remainder is 0. Then 8 into 1 is 8, plus 3 is remainder is 3. So this, the remainder is 1, 3, 0. So we have to write in reverse order. So it will be 1, 3, 0, base 8. This is base 2, and this is 8, 3, 64. So 64 plus 24, 88. Yes, so that's correct. Now let's convert the same number in hexadecimal. So 88, now 16 into 5 is 80, remainder is 8, and now nothing is remaining, so it will be 5 into 8. So 5 into 8 in 16, so 16 into 5, 80, plus 8, 88. So that's also correct. Let's take another number, 90. So we have to convert this 90 into binary. So it will be 2 into 45, 90, remainder is 0. 22 into 2 is 44, the remainder is 1. Then 2 into 11, 22, remainder is 0. Then 2 into 5 is 10, remainder is 1. And then 2 into 2, 4, remainder is 1. And then 2 into 1, 2 into 1, 2, the remainder is 0. So now write this in reverse order, 1, 0, 1, 1, and this one. So 1, 2, 4, 8, 12, 16, 28 plus 64, 64 plus 28 plus 64. Now I am going 1, 2, 4, 8, 10, 26 plus 26, it's 90. So that's also correct. Now let's convert the same number into octal. So we have to divide with 8. So 8 into 8 and then 1, 0. So 1, the remainder is 2. Okay, 11 into 8, 88 plus 2 is 90. Then again 8 into 1, 8. 8 into 1, 8 plus 3 is 11. So now the remainder is 132. So this is the same number is 90. In octal would be 132. So 64. So 64 plus 22, 24, 88 plus 2, 90. So this is correct. Now let's take another one. Now the same number we will convert into the hexadecimal, and this is 90. So 16 is to 5 is 80, and the remainder is 10. And now no, okay, so this will be the 5 is lesser than this one 16, so this is the remainder, and the earlier remainder was 10. Now it will be 5 and then it will be a, so it will be 5a, and 16 into 5, 80 plus 10 is 90. So this is how you can convert any decimal number to any target based system. Just a simple rule, no any confusion. Now we have to convert from any other number system to decimal number system. So just think on any decimal number system. So what is this? In actual, it is the sum of the digits multiplied by 10 to the power n. So how? So just say 0, 1, 2. So now I will write this number as 1 digit, and the base, what is the number is this in decimal? So write it here as a 10, then the square plus the next digit is 3, and we are using decimal number system, so this will be 10, and then again 1 plus the next digit is 7 into 10 and 0. So it will be 100 plus 30 plus 7, so that will be 137. So this is how the 137 has been formed. So this is the sum of digits, okay, multiplied by 10 to the power n. If you got this, then everything is clear for you. So now you have to replace only this. You have to replace this 10, the base system, and replace with any of the base system which you have, binary, octal, hexadecimal, and then you will get your answer. So I'm just taking one example. So let's say if this is the same number in octal, so what will be the result? So if someone says, okay, this 137 in octal, convert it to decimal. So we will take this one as 137 0 1 2. Same, I will write here 1 into, this was the decimal, but now we have this octal number, so we will take as a 8 into 2 plus 3 into 8 into 1 plus 7 into 8 to the power 0. So it will be 64 plus 8 into 24 plus 7, so it will be 95. So this is in the decimal 10, 95 in decimal. So this is the way you can convert from any number system to decimal. Now let's verify whether the result we got is correct or not. So 95 divided with 8, so 11 into 8, 88, so remainder is 7, So again 8 into 8 plus 3, so 137. So of course 137 in octal is equivalent to 95. So this is just a simple rule. I'll just take some more example. Let's take another example, and that is 75, which is given in octal. Okay, so we have 75 in octal and we have to convert into the decimal, so it should be around 68 into 7, 56. The result should be 61. So now I will just, how we can do this one, we write it here 7501. Okay, so this is the digit 7 into, and what is the base? Base is 8, and then 1 plus 5 into, again the base is 8 and 0. Okay, now 7 into 56 plus 5 is 61 in decimal, so this will be 61. Just verify this one. So how can we verify this one? 61 8, so 8 into 7, 56 into 5, and then 8, already 7 is less, so 7 into 5, so we got the 7 one, so that's correct. Let's take another example, and that is BA in hexadecimal, and we have to convert this into decimal. So it says BA 16 hexadecimal, so it should be 16 multiplied by 11, 16 multiplied by 11, 16 multiplied by 11 plus 10. So how much it will be? 16 plus 1 and 17, it should be 186, I guess. Okay, so let's do it. So this one which says 0 and 1, so we will put here as B into base is 16 into 1 plus A into base is 16 into 0, and B is equivalent to 11 into 16 plus A is equivalent to 10 into 1. So what I did the same thing. I multiplied 11 into 16, so it will be 6 and 176. Yes, so it will be 186. This is just a simple, no any hard calculation or something. Another number 11001110, take 1 2 4 6 8 16 32 64 96 and 1 2 4, so it should be 102. So now we will convert this one 0 1 2 3 4 5 6. Okay, so the 1 multiplied by base is 2 to the power 6 plus 1 multiplied by 2 to the power 5 plus 0 base 4 plus 0 multiplied by base to the power 3 plus 1 multiplied by base 2 to the power 2 plus this one 1 is to base to the power 1 plus 0 multiplied by base to the power 0. So now it will be 2 to the power 6 is 64 and 2 to the power 32 plus 0 into 0 0 plus 0 plus 1 2 into 2 4 plus 2 to the power 1 into 1 2 and plus 0. So it will be 96 100 102 in decimal number. So this one 1100 110 in binary is equivalent to 102 in decimal. Now take another example which says 1F2 in hexadecimal and 2 decimal. So 1F2 hexadecimal to hexadecimal to decimal number. So it should be how much? 16. No, it's difficult for me to calculate as of now, so I'll just take this one. So 0 1 2, so we will take this one, 1 multiplied by 16 base. That's the main reason I got confused. 16 is 2 plus f multiplied by base into 1 plus 2 multiplied by base to the power 0. 16 is square is 256 if I'm not wrong, and then 16 into f is 15, so 15 into 16 is 9 240 plus 16 to the power 0 is 1 into 2 will be 2, and that would be 256, means 400 450 490 460 498. Calculation might be wrong, so don't blame me, that's what I wanted to say. So this will be 10. We'll just verify that whether our calculation was correct or not. So I'll just take this one, let me erase the board. 498 in decimal we have to convert into the hexadecimal, so we will divide with 16. So 16 3, there would be 16 is to 3, 48, 1 into 8, so it will be 1, the remainder would be 2, then again 16 into 1, there would be 15. So that's it. So now for f we have representation as what? F. For 15 we have f, so 1 f2, so 1 f2, that's correct. So now I'll just take one more example. Let me take 3 7 and 4 in octal and convert it to decimal. So how we can do this? 0 1 2, so 3 into 8 base to the power 2 plus 7 multiplied by base is 8 to the power 1 plus 4 into base is 8 to the power 0. So that would be 64 into 3, 192 I guess. 64 and 192 might be 7 into 8, 56 plus 801, I mean 4, so 60, and so 260 minus 8, I guess 252. So the number was 374 in octal is equivalent to 252 in decimal. So just let's verify that's 252 in decimal. I'm just converting the 252 into the octal, so I'll just take 8 into 3 is 24, so 1 is to 2, so 1, the remaining is 4, then 8 into 3, so remaining is 4, so now 374. Yeah, that's correct. So this is how simple it is. So converting from, so I'm just summarizing this. So to converting from decimal to any other number system, you just have to divide the decimal number with the target base system. If you are converting from hexadecimal, binary or octal to decimal, so you have to find out the sum of digits multiplied by base to the power n, so like which I did. So this is how it can be done. Now let's see some more conversion. Now before proceeding further, I just want to tell you about one method through which you can convert any binary number to decimal very quickly, and that will be helpful in converting this number. So just take this one, 1001001. So what will happen is, because we are using this binary number, so just mark it as 1 2 4 8 16 32 6. Whatever the number is off, I mean the 0 bit, that won't be, and whatever the bit is on bit, so that will be calculated. So if you want to convert this into binary, so that will be, because see, the one value is 0, so that won't be counted, okay, and 2 bits it's counted, so it will be 2 plus this is the 0 bit, so it won't be counted, and this is the 8 bit, so it will be counted. So this is also 0 bit, this won't be, this is also 0, so that won't be counted, and this is on bit, so this is 64 will be counted. So this will be 64, 8, 72 plus 74. So again just take another example, 1 1 0 1, so put 1 2 4 8. So this is the off bit, otherwise all the 3 bits are turned on, so you have to add this one 8 4 and 1, so it will be 15. Okay, so this is the way you have to convert any binary number to decimal number. Just take another example, 1 1 0 1 1 0 1. So you have to mark it as 1 2 4 8 16 32 and 64. So it will be, this is on bit 64 plus 32, 96 plus 8, 104 plus 4, 108 plus 1. So this will be 109. So this is how you can convert any binary number into the decimal number very quickly. One more thing I would like to tell you about the binary numbers. So if we have only one places for binary bits, so it can be either 0 or 1. So if we have number of place, then what is the total number of possibility? So if we have 1, so it can be either 0 or 1, so the possibility is 2. If we have 2 places, so it can be either 0 0 0 1 1 0 1 1, so the possibility is 4. And if we have 2 bits, so again if we have 3 bits, so 3 bits the possibility would be 8, and if we have 4 bits the possibility would be 16. So just takes 3 bits, so 0 0 1 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So 2 4 6 8. If we know the number of places available for binary bits, we can find out what will be the total possibility. The number of total possibility is 2 to the power number of places. So if you have one place, so the possibility is 2 to the power 1 is 2. If you have number of places 2, then it will be 2 to the power 2 is equal to 4, and if you have total number of places 3, then it will be 2 to the power 3 is equal to 8. So why I am saying this, because as you all know, in hexadecimal you have total number of digits is 16, and in octal you have total number of digits is 8. So it's clear now, to represent hexadecimal you will require 4 number of bits, and in octal you will require only 3 number of bits. So sometimes people gets confused about for hexadecimal how many number of bits they have to take, either 3 or 4. So this is the most common confusion. So if you remember that hexadecimal is have the 16 total number of digits are 16, so that's the very clear that you will require 4 number of bits, and if it is octal then you will require to have 3 number of bits. So now I will tell you how to convert. Let's take an example, and in this side we will convert any binary number to hexadecimal, and this side we will convert from binary to octal. So the example is 1 0 0 1 0 0 0 1 0. Just take this one, and we have to convert this into hexadecimal. So as I told you that for hexadecimal you will require 4 number of bits, so just make pair of 4. Okay, and whatever are left, so you can put extra 0 to make the pair of 4. So now you will get this number, and now convert this binary number into decimal. So it would be 8 and plus 2 is 10, and this one will be 1 2, this will be only 2, because 1 2 4 8 and 2 bits are on, so it will be 10, and then it's 1. So now you got to know that 1 to 10 in hexadecimal 10 is represented with A, so it would be 1 to A. Now take the another number, that 1 1 0 0 1 0 1 1 0, and you have to convert this into octal number. So now you are converting this number into octal, so you have to make pair of only 3, this one this one. Convert this into decimal number, so it would be 124, and this one 1 2, and this one 1 2 4 6, so it would be 624. See, it is one of the easiest way to convert from binary to hexadecimal or octal or vice versa. Now take the another example, 11000101. So what can we take, because it's already so easy. Okay, so make pair of 4, so it will be again, it would be 10, and this would be 12. So for 12 we use C, and for 10 we use A, so it would be equivalent to CA in hexadecimal. And now take the another example, 1000100101. So and you have to convert this into octal, so just make pair of 3, so I'm just, this is a bracket, and then again make pair of 3, so it would be 5, and then it would be 4, and then it is also 4, so 4 4 5. So this is how you can convert from binary to either hexadecimal or octal. Now I will tell you about how to convert from octal to hexadecimal. Now let's take the same number and convert it into binary. So the number is 12A, and we have to convert it into binary. So the first is A, so for A is 10, and then 10 you have to convert into binary, so you have to 8 in 4-bit you have to write, correct? So 8 is on, then 4, if we will turn it on it will be 12, but so we won't turn it on, so 0, and then 2, and then 0, so it is equivalent to 10, and then 2, so for 2 we use 0 1 0 0, so this is equivalent to 2, this is equivalent to 10, and for 1 we can use 0 0 0 1. So this is how you can easily convert from hexadecimal to binary. The same way in octal you have 6 to 4, so you have 6 to 4, and you have to convert into binary. So just take this one, 6, so 6 you can represent 1 1 0 and 2 0 1 0, and for 4 you can take 0 1 0 0. So this is how 1 1 0 1 1 0 1 1 0 0 1 0 1 0 0. So this is how you can easily convert from octal to binary. So this is very easy for converting any number from binary to hexadecimal or hexadecimal to octal. Now every possible conversion I have completed this, and if you are still having some confusion, so you can rewatch the same video, and otherwise I'll just tell you one other method by which, if you know how to convert from decimal to binary, then you can convert from any number system to any other different number system. So that is pretty easy, but make sure you know very well how to convert from decimal to binary and vice versa, so that way you can convert any number in just few minutes. So as I told you that if you know very well how to convert any decimal number into binary, then you can convert into any different number system. So 78, so I'll just take it 64, 32, 16, 8, 72, and then 4, 76, 78, so 0. So this is equivalent to 78. So just take see 1 2 4 8 16 32 64. So what I have done, 64 plus 8 72 plus 4 76 plus 2 78. This is how I can calculate easily. So now you have converted this number into binary, so we got this into binary. The first rule is convert that number into binary, okay, and now we will convert the same binary number into octal. So for octal we have to write the same number 1 0 0 1 1 1 and then 0. So now for octal we need pair of 3, this one and this one, so it will be equivalent to 6, and this one is 1 and this one is 1. So in octal this would be 16, so 8 64 plus 8 72 plus 6 78. So this is all in octal. Now take this one, the same number 1 1 0 1 0 0 1 and make pair of 4 4, this one 0. So it would be 8 4, it is 14, and this will be 1 2 4 4 14, and for 14 we use E. so it will be 4 and E and 16. So 16 into 4, 64 plus E, 64 plus 14 plus 14, 4, 4, 8, 78. So you can easily convert from any number system. Let's take another example, say 152, and you have to convert this number into binary, octal and hexadecimal. Again, as I told you that first you have to convert this decimal number into binary, so it would be 128 plus 64, no, plus 32, 150, okay, 150, 32, then 16, 8, 4, 2 and then 1. So just calculate it, 1, 2, 4, 8, 16, 34, 62, 128. So what I have done, I have turned on only these bits. So 128 plus 32, 150 plus 2, 150. That's so easy. So 152. So we have converted easily. Now I will convert the same number into octal. So I will write 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1. So make pair of 3. So it would be, either you can put 0 or not, it is not required, it's totally depend on you. So it would be 1, 2, so this would be 4 and this will be 1, 2. This will be in octal, and same way you have to convert this in binary. So it would be 0, 1, 0, 0, 0, 1, 0, 1. So make pair of 4. So 1, 2, and then it would be 1, 2, 4, 8. 1, 2, 4, 8. So it would be 12, and 12 is equivalent to C. A is 10, B is 11, C. So this will be C2 in 16. So this is how you can easily convert any number system to any different number system. Let's summarize this. So to convert from decimal number system to any other number system. So what is the rule? Divide the decimal number with the base of target number system, correct? And then write the remainder in reverse order, correct? Now the second one is to convert from any number system to decimal number system. So in that, what you have to do, put the number starting from 0, I mean whatever the digit we have, put the number starting from 0 on each digit from left to right. So from left to right you have to put 0, 1, 2, 3, and then use the formula D1 as a digit 1, this one digit 1, into base, whatever the base of this number is, into the n, and whatever the value of n is, plus again d2 base, the base will be same, and again the power is 2, and then add all this one. And even if you are not able to remember any of these steps, so you just have to apply this general solution which I do. Okay, so now convert the number into binary. Okay, so you know very well that how to convert any decimal number into binary. So convert that number into binary and then convert into target number system. And one most important thing you have to remember, that in hexadecimal you have to use 4 bits, and for octal you have to use 3 bits. So now that's all about number system.